So good evening. I am Chomak Nag, a research scholar at School of Mathematics and Statistics, University of Hyderabad. So today I will solve a problem of week 7 from partial differential equation assignment of previous year. So let me first show you the questions. Uh, Question is question number 3. So it is given that f is a continuous function from r cross 0 infinity to r such that fx is also continuous, and f is such that for every x in 0 1 fx is identically equal to 1 for x in close interval 0 1 and t positive. And now you be the solution of this Cauchy problem. It is a non-homogeneous problem. utt minus uxx, it is equal to f of xt, the wave equation, and ux0 initial condition is 0 and utx0 is 0. So you have to find which of the following statement is correct. So there are 4 statements given. So let me first write the question. Ramesh, you saw the question now clearly. This is the question. So let me write. If you respond, then it will be better. Okay, let me write the question. That f from r, it is a continuous function such that fx is also continuous. And f derivative of f with respect to x. Uh, and for every x in close interval 0 1 fx is identically equal to 1, and t is positive if x comma t is identically equal to 1. This is given. Now u is the solution of the Cauchy problem. Let me write the problem. U is a function of x and t, the notation. So u be the solution of Cauchy problem minus u x therefore x t, where x is in r. Please carefully look at the region also. X is given in r and ux comma 0 is 0 and ut of x comma 0 is 0 or x in r. X in r. Now let me show you the options. Which of the following options are true? Correct, you have to show. So it is given, first option is there exists a capital T such that x goes to uxt is constant on a sub-interval of close interval 0 1. So do you know how to solve this equation, Ramesh? Means this is a non-homogeneous wave equation. Okay, somebody wants to join. Hello. Where is Ravi? Hello.
Yes, sir. Good evening, sir.
Good evening. Oh, is my screen visible? This is question number 3.
Yes, sir. Visual now.
Okay. So it is given that f is a continuous function such that fx is also continuous, and f takes the value 1 on close interval 0 1, and when x is in close interval 0 1 and t positive. So now it is given that u is the solution of this Cauchy problem. Okay. utt minus ux is equal to fx, and ux0 is 0, utx0 is 0. That I wrote just now. Now, the which of the following statement is correct, you have to identify. First option is there exists t such that x goes to uxt is constant on a subinterval of 0 1. So, do you know how to solve this equation? You know Duhamel's principle or something? Ruby or Ramesh? Anyone? This is the given. Do you know what is the solution of this type of equation? It is by using Duhamel's principle. You know, or should I will tell otherwise. Yes, you response. Okay, so I will tell. No problem. Duhamel principle says that here comparing this with the this equation. Suppose let me comparing this equation with the general equation. I have c equal to 1, right? So here c equal to 1, and by Duhamel principle we have what is u. You know what is u. Suppose this is I call phi of x and this is psi of x. Then what is u? You know? Anyone? X plus ct. Here c is 1. So I directly write x plus t phi plus phi of x minus ct. C is 1 plus 1 by 2 into c integral x minus ct to x plus ct. Here c is 1 everywhere. So I put only x plus t minus t and x plus t. Psi of something. Some says z. Dz plus for the non-homogeneous term you have to integrate. What is that? Plus again 1 by 2 into c. C is 1 integral 0 to t into integral x minus t plus s to x plus t minus s if function the non-homogeneous function that is given dy ds. Is it okay? Robi and Ramesh, hello. Is this okay? Visible or and you are audible? I am audible. Hello. Duhamel's principle. I wrote the solution of the general non-homogeneous wave equation. Hello. Please response. Any one of you?
Yes, sir.
Okay. 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 It is. This is the solution. General main solution. Now my phi is 0 and psi is also 0. So this part, this from this part to this part, it already becomes 0, right? My phi and psi are 0 from the given problem. So now I just replace phi and psi by 0 0. So here my solution is I will write here phi is identically equal to 0 equal to psi also. So uxt solution is given by uxt equal to integral 0 to t integral x minus t plus s to x plus t minus s fys ds. Now there is some condition given on f, that is it is given that f is a continuous function such that fx is also continuous, and for every x in closed interval 0 1 t positive fxt is equal to 1. So that means f is identically equal to 1 on the interval close interval 0 1. So I will take very small t and very small t for that, and very small x, such that these two number x minus t plus s and x plus t minus s, these lies between close interval 0 1. So that I will put f equal to 1, because it is given that f is identically equal to 1 on this interval only. Okay, on this interval. So that's why I will write what I tell now, that since it is given f is identically equal to 1 on 0 1 cross say t is positive, so r plus r plus. So we choose, so for very small t and x, both very small t and x, we choose let me erase 4. Choose very very small t and x such that, sorry, both the number x plus t, x minus t plus s and x plus t minus s, both lies on close interval 0 1. So that I can replace the f by 1. Okay, let me go to next page. So what I will get in that case, then we have uxt equal to half of integral 0 to t integral x minus t plus s to x plus t minus s 1. I replace f by 1 into dy ds. Okay. So it is just one integral is and this is x plus t minus s minus x plus t minus s ds. So uh, x will cancel out, and this is half of 2 into t minus s, right? 2 into integral 0 to t minus s ds. Is it okay? X cancel out. So here also 2 and 2 cancel out. So here it becomes, again, integral of t minus s is minus half of t minus s square. The limit is from 0 to t. So if I put it, I got t square by 2. But t is very small. As I choose. So, is it okay, Robi and Ramesh, regarding the calculation? Uh, Hello, Robi, is it okay regarding the?
Oh,
Huh?
yes, sir. Doing, sir. Last step, I'm doing by myself. The last step.
Okay, okay, you do. After finishing, you tell me if you got t square by 2 or not. I will show you the question. So what you have to choose, the correct answer is which one of the following is correct. So first question is given that there exists capital T such that x goes to u xt is constant on a subinterval of 0 1. So you got u is equal to t square by 2 or not? Robi, I will show you my calculation.
Yes, sir. Correct, sir. T
Okay,
square by 2.
okay. So the question I will show you, the first option is that there exists capital T such that the function x goes to uxt. That means you fixed small t at capital T. Then is it constant on a subinterval of 0 1 or not? That you have to check. So option A is x goes to uxt. There exists capital T. That there exists capital T positive uh, such that this x that goes to uxt, that means uxt is constant or not, is constant on a subinterval of 0 on a subset of 0 1 say subinterval. Close interval. So that means this means that you fix small t at capital T, then you got the function, then x you got the function x goes to u x comma t, right? That is fx. This means that some f is there such that fx is equal to ux comma t. That means you fix small t at capital T where capital T is positive. So in that case u is what I got uxt equal to small t square by 2, right? So here in that case what will happen? At t equal to, if I fix small t at capital T, I got t square by 2, right? So is it constant or not? Tell me. Because I fixed t.
Oh, yes, sir. T square by 2 is constant. Capital T square by 2.
Because I am fixing small t at capital T. So I am fixing this. So this is option A is correct. So option A is correct. Constant. So option A is correct. Now let's move to option B. Option B is that there exists capital T such that for every small t the function is constant on the subinterval, which may depends on t. No. Is it true? Uh, option B. Hello? There exists a capital T such that for every small t the function small t in 0 to capital T the function is constant on a subinterval.
Sir,
X
we
goes
need to check now.
no, the same thing. Here, what is the option I am writing? Tell you. It is saying that there exists a capital T which is positive such that for every small t in close interval 0 to t, sorry, in open interval 0 to t, the function x goes to uxt. It is constant or not? It is constant or not? Tell me. As you got uxt equal to t square by 2, right? Now you are fixing some capital T. Then suppose here 0 to capital T, you fix t. Then you are saying for any t here, you go x goes to uxt is constant. It is true, na? Because for every fixed small t, because for every fixed small t,
Sir, we'll get T square by 2 in each case
huh,
for every T.
for every t, and you have to take small t belongs to this close interval 0 to capital T, sorry, open interval 0 to capital T, right? So there you can find there exists a capital T such that for every small t the function is constant. So this is true because after fixing capital T you are finding small t, right? So for every fixed small t in close open interval 0 to t, uxt is constant for every fixed small t. So option B is correct. Is it okay? I am fixing small t in the interval 0 to t. I will show you the question again. Question is here. There exists a capital T such that for every small t, the function is constant on the subinterval of t. 0, 1. Is it okay?
Sir, then that which may depend on t. What does it mean?
May depend. It may not be depend, but may depend, because may depend means, as here I choose here I choose very small t such that these two numbers lies between 0 and 1. So the subinterval also depends on this t, right? And I am taking the function x goes to uxt, right? So fx equal to uxt, something like that. So the subinterval may depends on t because I am fixing this number between 0 and 1, because my f is given 1 on this close interval 0 1 only, right? That's why the subinterval may depends on t. May depends on small t. Is it okay?
Yes, sir. Proceed, sir.
Okay, so option C, you tell me there exists a point x comma t such that uxt equal to t square. Is it possible? There exists a point x comma t such that uxt equal to t square. Is it possible? From here. So let me go to next page. Option C, they are saying that there exists t such that ux comma t equal to t square. There exists for some x comma t in open interval 0 1 cross r plus something. Is it possible, Robi? What do you think?
Sir,
No, it is not possible, because I already got uxt equal to t square by 2, right? For any
huh.
x comma t in open interval 0 1 cross r plus. This is true for any x comma t, right? Uxt equal to t square by 2. So it is not possible that uxt become t square for some x comma t. So it is false. It is false.
Okay, sir.
False. Because I already got uxt equal to t square by 2, not t square. Sorry, let me write option D clearly. Option D is that question is question is question is uxt, there exists a subset of the set 0 on which uxt equal to t square by 2 holds. Is this true? I already got uxt equal to t square by 2, right? There exists a subset of this is true. True, because
Huh. This is for every,
huh,
every
u
x of t, na?
huh, uxt equal to t square by 2 on a subset, they are saying. If they are saying for every x, this is also true. Suppose option D is given that there exists a point x comma t, like option C. There exists a subset, they are saying. This is also true. On a subset also it is true, because it is true everywhere in 0 1. On a subset of 0 1 cross r plus means 0 infinity. So this is true. So options 2 are A, B and D. Okay. Okay. Is this question clear? Then you see.
Yes, sir. Got, sir.
Okay. So I will move to the next one. These are done. I will go to 7. Question number 7. Question number 7 is same. Just you have to find the value of u1, 3. You check it is a Cauchy problem. Again, a non-homogeneous wave equation. And the bound initial condition is given 0. Ux 0, 0, ut x, 0 is 0. U0 boundary it is given 0 also. So we have to find the value of u1, 3. So it is given an initial boundary value problem, right? With Dirichlet boundary condition, and fx means the non-homogeneous part is 4x, which is an odd function. So we can solve this problem in by using Duhamel's principle, right? Just now I wrote the solution for Duhamel's principle. So let me write the equation. Ruby, you understand the problem first of all?
No
This,
sir, एक बार फिर से मतलब problem.
sorry, what you tell?
Sir, did not get the problem.
Okay, is it visible?
Yeah, it is visible.
It is given that you this is the this is a Cauchy problem. You have to find the solution u at the point 1 comma 3. You have to find the value. Just a Cauchy problem, nothing. A non-homogeneous problem. So you have to use Duhamel's principle.
Okay sir.
So you know now Duhamel's principle I just wrote in the previous problem number 3. I just wrote now this is the Duhamel's principle solution. UXT this thing. Okay, so I will write the same thing where phi and psi are 0 here again because in bound initially it is given 0. So let me write the equation utt minus uxx equal to 4x. This is a 4x is an odd function and ux comma 0 and ut of x comma 0 both are 0. Then this means phi and psi are 0, right? And boundary is 0 t is 0. This is the region is important. This is true for I think x belongs to x greater than 0 and t greater than 0. Okay. So here it is x is positive and t is also positive. And here it is x, it is true for x greater than or equal to 0 and here it is true for t positive, right? So by Duhamel's principle, what is the solution? Let me write by Duhamel. Uxt equal to what? Can you tell me? Phi and psi are 0. Can you tell me directly, Ravi?
Yes sir, phi and psi.
I will tell you, I will show you the principal solution. This is the solution that I put right one. Ux equal to half of 5 x plus ct. C is my 1 here again. Plus x minus ct plus 1 by 2c integral this plus 1 by 2c for non-homogeneous part. So here my this from this to this it will 0 na, phi and psi are 0. Only f is non-zero here. So it is what? 1 by 2 integral 0 to t integral this f ys dy ds, right? This
Yes
is
sir.
phi and psi are 0 only, just put 0. Integral of 0 is 0. So I will directly write integral 0 to t into integral. You remember the formula, huh? X minus, we write it clearly, half integral x minus t plus tau. Let me write it as tau. Last problem I use s, x plus t minus tau, f of say sigma comma tau, d sigma d tau. So my fx is 4x, and f of sigma comma tau is here 4 sigma. That means f of x comma t is 4x, something like that. So I will replace f by 4x sigma. So integral 0 to t into integral x minus t plus tau to x plus t minus tau 4 sigma d sigma d tau. So just do the integration. This is a half integral 0 to t integral sorry, no need to put integral. Directly sigma integration is sigma square by 2, then I get 2 sigma square at the point x minus t plus tau 2 plus t minus tau d tau, right? So 2 cancel out, just integral 0 to t. Uh, okay, x plus t minus sigma whole square minus x minus t plus sigma whole square d tau. Is it okay up to this line? This is uxt. Up to this line, is it okay?
Yes, sir. Correct, sir.
Okay, now you have to find u1 comma 3 by the question. You have to find u1 comma 3. So replace x by 1 and t by 3. So equation become so that you no need to solve this whole integral. Just by putting x and t, I got 1 plus 3 minus tau whole square minus 1 minus 3 plus tau whole square beta. So this is equal to, let me write it in page. This is equal to half of integral 0 to 3 4 4 minus tau whole square minus tau minus 2 whole square beta. So this is equal to again the integral. Now I am doing the integration. It's a trivial integration. Tau minus 4 whole cube by 3. The range is 0 to 3 minus tau minus 2 whole cube by 3. The range is 0 to 3. Okay. So this is what? Minus 1 cube by 3 minus minus 4 cube by 3, right? Minus 4 cube minus 1 cube by 3 minus and plus. This is minus 2 cube by 3. Is this okay? Minus 1 minus 1 minus 1 plus 1. Is it okay? Okay. You got up to this, Ruby? You are doing the with me or something. But is it okay this calculation? Somebody wants to join. Hello, is my screen visible? This problem, Sasha.
Yes, sir. It is visible now.
Okay, so I am solving problem number 7, already just solved. So this is a Cauchy. You have to find the solution of this Cauchy problem at the point 1 comma 3. This is a non-homogeneous problem, so you have to use Duhamel principle. Here phi and psi, that is initial condition, at 0, right? So by the Duhamel principle, I have only the non-homogeneous part here. By Duhamel principle, u is this. So now f is 4x, so f sigma is 4 sigma. So I just integrate this and find the value of 1 comma 3. So I got 80 answer. Just you have to put the solution in what is as in Duhamel's principle, how to find u, and then replace x by 1 and t by 3. Then you got the answer. Is it okay for you, Ruby, and you just joined, Shashank? So Ruby, is it okay for you?
Yes, sir. Correct.
Okay, so answer is 18. Accept 18 is the answer. Okay, and Sasank, you understand what I did? I'll just tell briefly. If you tell me, then I will. Huh?
Yes, sir.
Okay, I just use Duhamel's principle, nothing else, and just replace x by 1 and t by 3. I got answer as 80. This is the answer. Okay, so let me move to the next problem. Problem number 8. Now you check carefully. This is again a Duhamel's principle, but here, can you tell me what is the difference, main difference here? I am showing you this code. This is visible, I think. Uh, I am showing you this question and question number 7. You just saw question number 7 once and you just go to question number 8. So what is the main difference? Again, you have to find the value at 1, 3 only, but what is the difference here? Can you
Sir,
tell?
the domain of x.
Excellent. Actually, domain of x is given as minus infinity to 3 and x less than equal to 3, this is given, and this is given for t greater than 0, but u at 3, t. But here it is 0 to infinity. But Duhamel's principle is true for what? For x lies between positive 0 to infinity and t positive, and this is also true for x positive. So what you have to do? You have to just change the variable so that it becomes like to solve using Duhamel's principle, right? Here x is in problem number 7, x is positive. The region I am saying, the problem number 7 region is x positive, t positive. But here, problem number 8, region is bounded by 3, x less than 3 and t positive, that is okay. But x less than 3. So you have to make some transformation to make x, and the transformation such that the equation remains same, but the region changes to same region as of 7. Okay. So what should be the transformation? Let me write it first. Equation. Question number 8. 8 is that utt minus uxx equal to 3 minus x, I think, for x belongs to 0 to 3. Sorry, not 0, it is minus infinity. Let me just rewrite. It is minus infinity to 3 and t is positive. And here boundary condition is initially it is given as 0 and ut also 0, but the region is again x less than or equal to 3, and u 3 comma t they are given as at 0 for t positive. So what should be the transformation so that this becomes, the region becomes x positive and something positive? So let me choose the new variable as xi. So what this should be xi? Can you tell? X lies between minus infinity to 3. So what should be xi? So that xi becomes, I have to write like 0 less than xi less than infinity, something like that, right? So that I can solve using Duhamel in here. So can you tell me what should be the transformation? Anyone? What should be my new variable in that case? Xi is my 3 minus x, so I have to write 0 less than 3 minus x less than infinity, something like this. So what should be my next two line? Just this two line. What should be my xi? I already wrote here. Anyone?
Sir, from 3 to.
No. My new variable xi, not region. I am saying region is minus infinity to 3 given. You have to make it as 0 to infinity to use Duhamel, right? Now you have to change some. You have to give some transformation to make this to make the region as 0 to infinity. So what should be the transformation? Let xi be the transformation. So what should I write? Xi equal to what? I just
3 minus x.
3 minus x, right? Perfect. Xi equal to 3 minus x. So how do we get? So you will get minus infinity less than minus x greater than minus 3. So now add 3 both sides. Infinity plus 3 is infinity. This means this. Is this clear? The what I wrote in the right hand side? Here. Is this clear?
Yes, sir, correct, sir. Infinity plus 3 is infinity
Yeah,
only.
on schedule. No need to worry. So I just rewrite it and my xi becomes this. So if I use the new variable as w, unknown as w, that is w of xi comma t is my u. U is 3. I replace x by xi, right? So I will write like this. Not u x 3 minus x comma t. I will write 3 minus xi comma t. Since I using new variable w. So what should be my w of xi? W of xi is what? Can you tell anyone? Minus u of x of this. Understand this line? Or I will write another for you. You understand this line, Ruby or Sasan? Anyone? This I just do derivative with this to xi. Consider 3 minus xi as x. No need to worry. Then what is that? U of w of xi means u of x comma t into u of x at x comma t into dx dz. Dx dz is minus 1, right? So this line directly here. Is it okay? Hello? Hello? This
Yes, sir.
is okay now?
Ah, correct, sir.
Okay,
Partial
so
differential.
just 1%. So w jaja u is uxx and wtt is my utt. Wtt is utt of same thing because there is no change in t. I just change in x. So my new equation is what? The new equation is uh, wtt minus wxx equal to, because I just replace u by w, equal to what? Equal to my xi for the region now. Region is 0 xi to infinity and t positive because I did not make any change on t, and w xi comma 0 and w t at xi comma 0 is 0 for xi greater than or equal to 0 here, because here my region is x less than or equal to 3. So I have to use xi. So x less than or equal to 3 means xi. Hello?
Sir, WTT minus WXX equals to xi. How, sir?
Because utt minus uxx is 3 minus x. From the equation given, utt minus uxx is 3 minus x. And I put xi equal to 3 minus x, the transformation. And I put I got that uxx equal to w xi xi. Because this is true for everything, for every x in 0 to 3. Okay, utt x comma t and uxx x comma t for every x in 0 to 3. And my uxx 3 minus I comma t is same as w xi xi. So I just replace wtt minus w xi xi is xi. I just replace by using new variable u and w and x
Okay,
and xi.
okay, sir, correct, sir.
Then u 0 comma t is 0 for t positive. Okay. So now you can solve this equation by Duhamel because you have the region 0 to infinity and everything is fine. So no need to worry. Now you can use Duhamel in W, right? Ruby and Sasan. Okay. Like the same, it becomes the problem. Looks like the problem 7, right? Because I got the region as a xi positive here. So I will solve. Move to the next page. So by Duhamel, my answer is Actually, I have to find u at 1 comma 3. So I just replace the variable xi at xi means 3 minus x. 3 minus x. So my x is 1 means xi become 2. So I have to find w 2 comma 3 by Duhamel. So it is since the phi and psi are 0 because there is homogeneous condition on initially. So w 2 comma 3 is half, c is 1, so half integral 0 to t, where t is 3, x minus t plus tau, by using the same like the previous thing here, x minus t plus tau. Here I put x equal to 2 and t equal to 3. Okay, because u13 means w2 comma 3. That's it. So 2 minus 3 plus tau, 2 2 plus 3 minus tau. My f is sigma xi, so only xi or sigma I write d sigma d of tau. Is it okay this line? Robi and Sasan.
Yes, sir, correct, sir. We have psi and phi is 0, 0.
Phi and psi are 0. Phi and psi equal to 0. So I got this. And u13 means w23. I just directly wrote the solution. I just directly wrote the formula. So I just integrate this thing. So this is sigma square by 2. So 2 minus 3 means minus 1 plus tau, and 2 plus 3 means 5 minus tau d tau. So this is just an integration half 1 by 4 because 2 and 2 comes here. 1 by 4 integral 0 to 3 5 minus tau whole square. Sorry, let me write it clearly. Minus tau minus 1 whole square. Whole square. D tau. Now integration is okay. Let me first no integration is okay. Let me break it. It is 25 a square minus 2ab plus b square minus 10 tau plus tau square minus tau square plus 2 tau minus 1. Yeah, is it okay? Okay. So tau square cancel out. This is 24, 5 minus 1, 24, and minus 8. Okay, 8 tau. So 1 by 4 integral 0 to 3, 24 minus 8 tau. Is it okay up to this line? So let me take 4 common. 6 minus 2 of tau. So 4 cancel out. So I got 6 into 3 minus 2 into half into tau square minus 9. So 18 minus 9 is 9. Is my calculation okay, or you want to tell something? It is 9. You check the calculation carefully. I just take 4 common and then integrate. Directly I wrote the solution. And see how this integration I wrote directly. If you have any question, you can ask. Hello.
Yes, sir.
Okay, na 9. I got answer as 9. So u 1 comma 3 is 9. Answer is 9. Okay. Okay, so I will move to the next question. Huh? This is a question visible. Question number 9.
Yes, sir, visible.
Okay, that it is given the phi and psi are C2 and C1 function, and u be the solution of this Cauchy problem. This is homogeneous. And solution is given by f of capital F x minus ct plus g x plus ct. Now such that f0 and f0 equal to z0. So now you have to find which of the following statements are correct. There are 4 statements. These are the statements. So let me You first read the question once, just quickly. So then I will go to my question number 9. So I will write the question. Question is that utt minus c square uxx is 0 and x is positive, t positive region, and u x comma 0 is phi of x and ut x comma 0 is psi of x and x is positive, not negative, and ux at 0 comma t is 0 or t positive. So my answer solution is what? They said that solution is uxt equal to f capital F of x minus ct plus g of x plus ct, where f and g c2 function, f and g belongs to c2 and f0 equal to g0. Okay, so this is the question given. Now you have to find capital F and capital G by which of the following are correct. So, any idea of doing this problem? It is just a Cauchy problem or a Hoebe equation. Ramesh and Ruby, who are there? Ramesh and Ruby. Sorry, Ruby and Shashank.
Sir, C1 and C2 are like line and complex plane, no?
No, C1 and C2 means continuous. C1 means C1 function means first time derivative is continuous. And C2 function means twice continuously differentiable.
Okay, sir, correct, sir.
Not line anywhere. It is a function. And a space. These are space. C1 and C2. Mm. Okay. C1, C2 means there it is twice continuously differentiable. The derivative of f and g are continuous on R. Say two times derivative. Twice continuously differentiable. Okay. So the solution is by Duhamel. What is not by Duhamel but what is the solution? Here phi and psi are okay, given non-zero. So phi of x plus ct plus phi of
Sir, are we using Dirichlet conditions?
yes. Duhamel means for non-homogeneous it becomes Duhamel. Here it is homogeneous because right hand side is 0. Utt minus c square ux is 0. Okay, you understand? Psi of say s ds. Is it okay? This is the solution. Now they are saying the solution is capital F x minus ct plus capital G x plus ct. Now you have to find capital F and capital G from here. Only you are giving that two condition. With that there are another condition u x0 is phi x and ut x0 is psi x. These are the condition given psi x. So what you have to find? Let me show you again. Question is find that f and g in terms of phi and psi, right? You can see that in that option it is given f and g in terms of phi and psi. So you have to find f and g. So I will do this. So what is u x comma 0? Can you tell me? It is suppose xt is f of x minus ct plus g of x plus ct. So what is u x comma 0? It is capital Fx. I just put t equal to 0. It is
Capital Fx plus capital G of x.
just I have to find solution. And what is derivative? Utx comma 0. From here, from the from where is my cursor is there. Uxt is equal to f of x minus ct plus g of x plus ct. So what is ut? Ut is what?
Sir, it will be minus c into f of t x minus ct plus
F dash, derivative, f dash.
F
You are
does.
defining f dash x minus ct, and now ct is 0, so I will directly write f. Okay, let me write x minus ct, then I will put t equal to 0 plus c g dash x plus ct, x plus ct, sorry, x plus ct at t equal to 0, because u t x comma 0 na equal to psi x. So it is minus c f dash x plus c g dash x, right, equal to psi of x. So f dash x minus g dash x is what? F dash x minus g dash x is minus 1 by c psi of x, right? Okay. So let me write this equation again. F dash x minus g dash x equal to minus 1 by c psi of x. So now I integrate this whole thing. Integrate in 0 to x. Let me write integrating on 0 to x this interval. So what should I get? Left hand side fx minus gx
Equals to,
equals to nil minus f0 minus g0 I will get now, because I am integrating in 0 to x. So for 0 also I have
yes,
to
sir,
write
correct, sir, correct.
minus 1 by c integral 0 to x. So I will replace x here. I will write psi s. Okay, not x all time. Is it okay this line? Hello? You understand that this line to this line I just integrate. Int means integrate. Now, yes, tell me.
Yes, sir. Sir, this ds, the second integral.
Ha, I just replace x by like every time I have to write x now. Here also x, and here if I write x, then it will not look good all time, because I am changing. It is s and x are integral 0 to x fs ds. This means integral 0 to x ft dt, right? This means integral 0 to x ft dt. Not it true. Everything is same now.
Yes, sir, correct, sir.
So that's why I write yes, not x all time. Just yes. Okay. So now given f0 equal to g0 in the equation. So let me solve the question. Given that f0 equal to g0 here, where is my cursor is there? F0 equal to g0. So put f0 equal to g0. So now f sorry if 0 equal to g0, it is given now given. So my equation becomes fx minus gx. F0 minus g0 is 0, so minus 1 by c integral 0 to x psi s ds. So suppose this is equation number 2. Let me give this as equation number 1. So how to find f? By adding 1 and 2. 1 and 2. I got fx equal to phi x by 2. I am directly writing, I will show you how it can 1 by 2 c integral 0 to x psi s ds. And uh, by subtracting I will get, or not by subtracting, let me write another thing. So, and since I have to find gx also, since fx plus gx is phi x, so gx equal to phi x minus fx. So this is, I just put the value of fx, I got phi x by 2 plus 1 by 2c integral 0 to x psi s ds. So let me show you the, this is gx. So let me show you, and this is fx. So show you what are the options given. Option are this f of x. Now they are saying f of xi. So if replace x by xi, so f xi equal to this. I think this is the correct option because I got fx equal to 5x by 2 minus 1 by 2c 0 to x. So replace x by xi because the option is given in terms of xi. So this is the correct option for f, option A, and for g I think this because I got plus. So A and D are correct. For G they are finding G eta. So replace x by eta for G. 5 eta by 2 plus 1 by 2. Yes. A and D and correct option. Okay. Ruby and Sasa. Okay.
Sir, once option A, so
Yes.
option A.
Yes, sir. Yes, Ruby. This is option A. Just replace x by xi because we are saying f xi. 5 xi by 2 minus 1 by 2c.
Certain plus and minus is there difference, no?
Yes. For F, for option A there is plus, there is minus. Sorry, and for option D there is plus. Yeah, I got the same thing. For option A there is minus. For option D there is plus for F and G. Just replace x by xi here and x by eta here. For they as they given. Okay.
So sir, f of x and g of x are together the solution.
Together to not
Uh,
solution, you have to find this solution is u is f plus g, f of x minus ct plus g of x plus ct, as they are saying. Now they are saying which of for which are the correct value of f and g, or which are the
okay, sir, correct, sir.
not correct, which are the correct expression for f and g, like that, not value. A and D are correct, that is the answer. Is this okay?
Okay, sir.
Okay, so it is 7 6. So let me do one problem more. Is it okay? This problem number 10. Are you okay or should I stop? Okay. If so, yeah, Ruby and Swami Hasan.
Yes, sir. Do it, sir.
Okay. So question number
Another 5 minutes, sir. Do it.
question number 10. Okay, no problem. I can do. Question number 10 is that identify all such f and g relation that are consequence of the boundary condition ux0t is 0. Now you have to find some relation between f and g such that ux0t is 0. Let me show you, let me write this thing in next page. Question number 10. So I have to write ux0t is 0. That I have to find. Now what is my u? U is that u is f capital F x, I think minus is there, yes, plus g x plus. Now what is ux? Can you tell me? Ux is what?
Sir, f dash x x
Yes,
f dash
x.
x plus g dash
No,
x.
not here. X is 0, not t 0. In my previous problem, t is 0.
Okay, sir. X is 0.
Ah, my understand.
F dash minus ct plus g
Ah,
dash plus g dash ct.
at x equal to 0, because here my x is giving us 0, right? Here 0, 0 comma t. So that is f dash minus ct plus g dash ct, right? Is it okay? Where t is positive, not negative. Is it okay? Up to this, Understand? I just put x equal to 0. So now you have to show it is given solution in terms of xi. So you have to put what you have to put to get xi. Tell me. Solution is in terms of xi. F dash xi, g dash xi, something plus minus. Region is important. T greater equal to 0. Here put xi equal to what? What should I put? Because let me show you question again. This is the question. So what should I put in as xi here? Xi is ct na. Can you get it? Then I get what? F dash minus xi plus g dash xi equal to 0. Where my xi is ct and xi is greater than equal to 0 because t is greater than equal to 0 and c is also positive. Understand? My C is positive and T is positive also. Okay, question number 10. You understand Robi or Sasan? Anyone? I just replace.
Yeah.
Okay, I just replace. Now you have to find what? F dash xi, you got f dash minus xi plus g dash xi equal to 0. Where xi greater than equal to 0. Is it there in options? Tell me. What I got is that f dash minus xi plus g dash xi. Here it is f dash minus xi plus g dash xi is 0. But I got xi greater than equal to 0. So is option B correct? Option B is
Sir, sir, Jai is everywhere less than 0, no? In all
no,
option.
no. In all options, I are less than 0. Okay, that is okay. But I got what? I got xi equal to ct and f dash xi minus xi plus g dash xi is 0 where xi is equal to ct where ct is greater than equal to 0 because c is positive and t also greater than equal to 0. It is given for t greater the actually it is given for t greater than equal to 0, right? Ux 0 comma t it is given for t greater than equal to 0. So my here I got xi greater than equal to 0. But in the option it is given xi less than equal to. So option B is false. Option A is already false because there is no minus. There should be plus. But option B is false because of the region. You understand? Hello.
Yes, sir.
Now option C is there is no derivative in option C. So you have to integrate the what I got. You have to integrate the relation. So what this line I am writing like this. You just check. It is minus. Is it okay? Is this line okay? I wrote. Is it okay what I am doing? Check the last line. Tell me these 4 lines are okay or not for you. Ruby and Sasan. Is this okay? You understand? Ruby and Sasan. I just integrate, nothing else. And I put xi equal, I just replace xi by minus xi so that I got the region as xi less than equal to 0. Previously my xi is greater than equal to 0. Now I just replace. So let me check the options. Option is option D. F xi minus g of minus xi is 0 whenever xi less than equal to 0. And I got like that only. F xi minus g of minus xi equal to 0 whenever xi less than equal to 0. So option D is correct. The correct answer.